As you can see on the slide, my name is Bob Sleigh. That's what you get with parents with a sense of humour. So I hope we're going to take you through my presentation. Hopefully we'll get a few laughs and smiles on the way. My mum always said a good sense of humour keeps you young, so hopefully we'll all feel a little younger at the end of my presentation, although I probably will feel a little older. So I want to talk a little first of all about mobile network capabilities. Here from down at the left we have 2G voice. I'm long enough in the mobile industry to actually remember this coming in and to help deliver this. And I have to tell you, it set me free. You don't hear many people say that about 2G data, but at the time I was working in a support organisation for one-to-one, the mobile network that then became T-Mobile, that then became EE. And travelling around the country, I quite often found myself in hotels doing on-call support at 4 o'clock in the morning. And in those days, again, perhaps surprising to the younger members here, there were very few telephony ports within a hotel that would actually support data. So you generally ended up sat in reception at 4 o'clock in the morning, fixing systems remotely. So along came 2G data. I suddenly was set free. I could now work from my hotel bedroom at 4 o'clock in the morning. The speeds then started to move on up, slowly at first into 3G, HSPA and then HSPA plus, getting us up then to about 20 megabits per second at peak, although very few users would ever see that. And then HSPA plus, and then we moved up to LTE, 4G LTE. Again, a peak speed of about 70 megabits per second. And at this point, really, video conferencing becomes a viable possibility within the environment. Now, I don't know, again, I'm dating myself here, but when I was a teenager, there was a TV programme that I used to watch called The Tomorrow People. They've actually just started redoing it, and it's on recently. I haven't seen it. But the Tomorrow People had little wristbands where they used to have a button where they could press the button and have video conversations with one another. Yeah. And I sat there as a teenager and thought, this is never going to happen. No way. And yet here we are now with devices you hold in your hand, with things you wear on your wrist, where we can do all that. My memory of the original programme is that their video was in black and white, although that actually may be the telly that we had when I was a kid. So today's Tomorrow People are now looking forward to LTE Advanced, 4G Plus by another name, where 4K video is a possibility. 4K video would expect to require perhaps 20 megabits per second for each video stream running across there. And so where are we in terms of LTE within the UK? Well, again, perhaps surprisingly to some people, the UK is now becoming a global leader within the LTE marketplace. We first had LTE in the UK in October 2012. By December 2013, we had over 2/3 of the population covered. That is one of the fastest rollouts of LTE in the world, and is by far the fastest take-up of LTE within Europe. The double speed LTE, which takes us from 70 megabits per second up to 150 megabits per second, is already available in certain areas, generally in the more urban areas, the built-up areas, but it is already available, and we hope by the end of this year we should, within the UK, have 98% of the population covered by LTE. So LTE Advanced, the 300 megabit version, started as a trial in November last year at Tech City. If you're lucky enough to have facilities at Tech City in the east of London, you can take part in that trial. That makes the UK the second country in the world to have LTE Advanced deployed. The first one was South Korea. And during that trial, the speeds recorded went up to 296 megabits per second, which makes it actually the fastest ever mobile speed recorded in a live environment anywhere in the world. And the expectation is that the first commercial LTE service will be available within the UK during this year. So, what's going to fill up all this LTE bandwidth that's being deployed around the country? So, mobile data is expected up and to the right, 9 times greater traffic overall than in 2012 will be by 2017. Mobile video makes up a significant amount of that, over 2/3, and has an even steeper growth curve, where 12 times more consumer video than 2012 and 5 times more business video. So we have lots of bandwidth, we have lots of demand. So the question then comes, what does good look like on video on an LTE network? How do you benchmark quality of experience? So this is all based on users. They're the critical point. What does good look like to a user? Is it different if it's a short-form video than a long-form video? Do live catch-up video on demand have the same requirements? Are users happier with different quality of experience, whether they're paying for the content that they're looking at or whether it comes free? The device type clearly makes a difference in terms of the capabilities that are available on the devices. Users generally have a choice between buffering or adaptive streaming. Which of those do users prefer? Is there an amount of buffering that users will accept, or a reduced bit rate that they'll accept? As devices and connectivity improves, does the expectation of users improve with it, increase with it? Are there places in video streams that people are prepared to accept worse quality, or do we have to, from beginning to end, support the same quality of experience? And again, another question, does it depend on the original quality of the video? Once you've answered those questions and you start to understand what good looks like, we start to look at the issues in actually delivering that quality of experience. So there are evolution in video codecs getting better all the time, essentially reducing the bit rate and the file size but maintaining a similar resolution. This helps to reduce network traffic, and the idea is that we can improve the user experience while using lower bandwidth. There's a multitude of codecs that are available, although there's some progression towards standardizing on a smaller number. High efficiency video coding, HEVC, has nearly halved the bitrate and file size of previous standard, which was AVC. If we take that technology and combine it with adaptive bitrate, we could actually provide a reduction in traffic while maintaining a higher quality of experience. However, as is usual in these things, HEVC is improving the situation by reducing the amount of the size of the files, but it's also part of the move towards ultra-high definition TV, which is likely then to push the actual bit rates for a stream back up to the AVC levels. And just as an aside, the photographs in the bottom are actually of my mom, so I guess she's right about the sense of humour. Oh, we're awake, good. So adaptive bitrate technologies. Historically, mobile video streamed at a fixed rate. If you lost your connection speed, your quality of experience suffered. You got buffering and loss. Users in general preferred for the resolution to be lower on the stream than to have it buffering. So there were some sites would allow you to select whether you wanted high definition or low definition. But once you'd selected that, you were hooked into that bitrate. So adaptive bitrate technology tailors the stream to both the device capabilities and the available bandwidth. When the connection speed changes, the bitrate adapts. So that reduces buffering, gives a better user experience, both in congested environments and at the cell edge, where it's more difficult to deliver high-speed connectivity continually. And it minimises the user interaction because the user doesn't need to choose a level of definition, of resolution. But there are some problems with adaptive bitrate technologies. It can lead to very unpredictable data usage. If you pick a stream to stream at standard definition, but if you start to get higher bandwidth available to your device because the network isn't in congestion, then in fact the content will stream at the highest bitrate available. And if you happen to be paying per megabyte for your data connections, that costs you a significant amount more money. So part of the move forward that helps us to deliver this is moving towards standardization. So adaptive bitrate and codecs together, the more codecs there are, the more bitrate techniques there are, means more and more copies of the data that you want to stream have to be held somewhere. So moving towards standardization reduces the number of copies that need to be held. So Dash is one such thing. I'll touch a little on it, but if people want to know more about it, there's an excellent presentation that was given by Thomas Kernan from Cisco at UKNOF27, and the presentation's available. And I guess probably a video of him talking about it. But Dash in itself is audio and video codec agnostic, so it will support any codecs that people choose to use. But the actual specification that's been written only provides specific guidance and format for two formats, MPEG-4 and MPEG-2 for transport streams. It allows multiple representations to be maintained, and it essentially works by partitioning a multimedia file into segments and has a description file that gives you the details of each of those segments in terms of the timing, the URL, the media characteristics such as resolution and bitrate. And this standardization should reduce the amount of copies that need to be maintained and should allow networks and operators to make selections based on network conditions, device capabilities, and also user preferences. So we also have TV running across mobile networks. Here we have an example of live sport drive-in data usage. This actually, 13th of January last year, I looked it up. The first one is, this was a good day for Manchester. The first day is Man United beating Arsenal, and the second one is Man City winning. I got that wrong, sorry. Man United beating Liverpool, Man City beating Arsenal. But the difficulty for an operator is that this breaks the normal capacity planning model of busy hour, where you have a fairly regular graph of usage, but those peaks take you way away from there and drive your capacity planning for peak. So what can we do? Sorry, this slide's a bit messy when it just appears all in one go. What things can mobile operators focusing on at the moment to try to improve things? So we're looking at whether we can cache mobile video. And if we start from the left-hand side of this screen, for a mobile operator, spectral efficiency is clearly the key to making the most of our resources. Spectrum's a very expensive resource and it is limited. So on the device front, where we have multiple millions of devices, there are products being developed where the machine learning, your device studies what it is that you're downloading and watching and attempts to make intelligent guesses as to what you'd like to watch next, allowing the operator to stream it to you in quiet times, therefore filling in the gaps really in the capacity. As we move towards the left, you get less and less advantage for an operator. So at the cell sites, we gain an advantage by more efficient use of backhaul. It's relatively, it's technology that's in development. It's very good for dense environments, and it does reduce latency to the device to a significant extent. However, it doesn't address any spectral constraints. It doesn't save us any spectrum. And it doesn't address the situation where you have a number of viewers wanting to view the same content at the same time. In connectivity sites, as we aggregate back, We can reduce the capacity within the core infrastructure, but not in the backhaul or the spectrum. It allows us to aggregate multiple thousands of cell sites into a single environment. So it does reduce the amount of equipment that we have to deploy, but there's no real advantage of deploying in connectivity sites rather than the aggregation sites. So in aggregation sites, smaller numbers, it does help with internet bottlenecks, is its main focus, and it does help to support operator optimization of video streams. But it's suboptimal for certain video content, perhaps YouTube, unless you're using Google Global Cache. And really, unless you've got an optimization platform in that site, there's no advantage over that than using a content delivery network. We could look at caching in the colo centres in London, but that costs us hosting cost. We require redundant capacity and only a very minor improvement in latency. So there's no real benefits there. The CDNs are sat in the same place. Pairing with them is inexpensive. They're optimized for video, and there's no significant investment for the operator there. However, there's no opportunity for operator optimization either. So multimedia broadcast technology, in terms of looking at live linear TV, BBC and Sky are predicting a rise in this over the mobile networks. The mobile network operators are currently reviewing both the commercial and the technical viability of these broadcast technologies. There have been some problems in the past. The current technological standard for LTE is Evolved Multimedia Broadcast Multicast Service, which is an odd name, but Huawei have built a technology centre to develop this technology. Qualcomm demonstrated it along with Ericsson at the Mobile World Congress a couple of years ago, and Verizon are threatening to run live broadcast Super Bowl 2014 over this technology. It makes incredibly efficient use of LTE spectrum. The current studies look as though there seems to be a positive business case for this technology. When you get above 3 users streaming the same content within a single cell area or a cell cluster. So it's specifically focused at kind of stadium events where we have lots of people all trying to access very similar content, and it starts to make sense there. So that's really a point solution that we can use for particular environments. When we look at the way that the overall picture, if we look at a satellite distribution model, we have the content provider, hi Mom, being distributed up over satellite networks down to your receiver dish and onto your telly. Across that environment, there's the alignment of technical roadmaps between suppliers. There's an ability to control quality of experience and an ability to perform end-to-end testing. When we compare that to the mobile distribution environment, you have the content providers. We rely upon the internet to populate the caching services at the CDN networks in the data centers at the co-location. We have operators and all of their networks, the various access technologies in the cell areas that need to be taken care of. And then when the content arrives at the device, there is issues with the device reception, with the chipset within it, with the application sat on top of it. And all of those need to work as a single coordinated whole in order to get a good quality of experience for the user. And when my mom can't see herself shopping on the thing, she only has one number, and it's mine. So she rings me, but there's very little I can do about this whole chain. So where does that leave us? So at the moment, there is a technology disjoint in the end-to-end mobile video chain. Without more communication and increased knowledge share between all the parties involved in that chain, the technological advances are not going to be fully exploited. So we've touched on several of these. We haven't really looked at video optimization platforms or content delivery networks. I'm sure there are people here who can talk much better about content delivery networks than I can. But the reality for an operator, there's no one single silver bullet that's going to fix this. We're going to need a constantly evolving toolkit of technologies in order to keep that quality of experience for our users up to the standard they're looking for. So where do we go from here? 2014, hopefully the year when mobile video becomes an ecosystem. Industry discussion and knowledge share is absolutely the key to getting this right. I don't believe it can be, that the operators can begin to fix this on their own. And in fact, I think it's probably true to say that any single party in that value chain who decides to work on an initiative themselves in isolation is likely to actually impact the overall customer experience. So an end-to-end understanding of that will lead to greater innovation, and we'd like to see the combined weight of the whole industry back in mutually beneficent technologies like perhaps MPEG-Dash. Globally connected mobile networks don't benefit any of us. I think the operators are actively pursuing this at the moment, and I expect to hear some announcements fairly soon that there is an initiative underway. Thank you. Hi, Neil.
Neil McRae from BT. I wondered if EE had looked at any way of re-encoding video for specific devices. So if you imagine someone pulls an ultra-definition piece of content and they're watching it on their iPhone, it seems like a bit of a waste of bandwidth. And I wondered if you looked at any way of kind of identifying the device and then doing some sort of re-encoding so that the user experience to that device was as best as it possibly could be.
Yeah, I think it's fair to say we've looked at it, but I think the point really that I'm trying to get across here is that trying to do that in isolation becomes impossible, because I can do that this week, but if the content providers change the way they deliver content to me, or the content delivery network decides to start to try to optimize the traffic that they're sending to me, then that generally interacts rather badly with whatever we're doing as an operator.
So could you share more, so to help that scenario, could you share more about the end user with the content provider? So imagine a world where you're able to signal, say Akamai for example, that the user who's requested this content's on an iPhone 5, send me that stream. Is that something that you'd be able to do?
I think that's something that's already in place.
Okay, yeah. All right. Okay.
It's my understanding. But as I say, that's fine if we have an agreement with Akamai that they will assume, and everybody in that chain will assume, that only we play with the video stream. And that's not currently the case.
Hi, it's Trevor Davis. Very impressive LTE speeds, if I may say. And I'm just wondering, how do you decide, well, first of all, what's the market for it? Who is it aimed at? And then how, obviously you must take up quite a bit of spectrum to achieve speeds like that. And how do you decide on the balance of, you know, achieving capacity versus speed in your customer base, really?
I think I'll try and answer that in small pieces, if I may. So the first answer, I think, is that in general it's a business proposition that's driving LTE forward in the UK at the moment. So businesses are seeing the advantage of being able to streamline video, I suppose, is as good as an example as any. I think there are some of the news reports that you see now on TV go over a 4G connection rather than some van with a cable, you know, satellite links and all the rest that used to go on. So I believe those are the kind of environments where it's making the most headway. I'm sorry, I've lost track of the second half.
Well, I just wondered, because obviously that kind of speed must take up quite a considerable chunk of spectrum. And so, you know, it's how do you decide how much spectrum to allocate across your network for a particular kind of service, really?
Okay, so I see myself as quite a technical person, yeah. But we have people who just blow my mind technically, who sit and work out spectrum allocation. It's something I'm glad I know nothing about. Yeah. I sit occasionally with them in the canteen, and you walk away from lunch thinking, you know, they live in a different world. Yeah. Right. So I'm sorry, I can't give you detail. Okay. I could probably put you in touch with somebody who could answer your question, but you probably wouldn't want to have much of a conversation with them. Yeah.
Okay. Any other questions for Bob?
They say about network engineers.
Yeah, they do. but they're
Okay,
wrong.
thank you very much, Bob. Sorry, was that one more question? No. Okay, thank you very much,
Thank
Bob.
you.